Hello and welcome to this video in which I will show you how you can specify latent growth curve models for free using a no-code graphical user interface. My name is Geiser, I'm an instructor with QuantFish. So let's get started. There's an exciting new feature that is available online called the lavaangui, which is a graphical user interface that allows you to generate confirmatory factor models, structural equation models, path models, and also latent growth curve models by drawing a path diagram. So let's take a look and see first of all where we find this GUI. You simply open up your browser window and then you can type in lavaangui.org, and that takes you to a website where you can first of all load a data set for analysis. So in this case, I'm going to go here to File and then Load Data. And you can see that the lavaangui allows you to open files in different formats, which is also really practical. So for example, the data could be in Excel spreadsheet format, or it could be an SPSS data file with the extension .sav, or it could be a simple text file with the extension txt. So in this case, I have my data in a simple text format. The data set is named growth.txt. So I'm going to click on that, and then I'm going to open this data file for analysis. You can see then the data viewer here opens, and it shows you the variables in your data file, so you can check that everything is correct. In this case, we have 4 measurement occasions, and here the idea is that we measured intelligence in the same individuals on 4 different equally spaced measurement occasions. Next, we can close the data viewer, which then takes us back to the main drawing pane here, where we can draw our path diagram. On the right hand side, you can see there are some shortcuts also provided that can make your drawing action even faster. Now you can see that here in the menu we have our 4 variables, so we could draw variables directly from that menu here for the analysis. We also have options to include latent variables and a mean structure, as well as covariance paths or regression paths. However, the simplest option to start a growth curve model is by just simply pulling the growth option that is already provided here in the menu. So when we drag that down to our drawing pane, then we can see that a dialog window here opens where we can select the relevant latent growth indicators. In this case, we're going to analyze all 4 time points. So I'm going to select all 4 variables in the data set and then click OK. And then you can see that a linear growth curve model is already being drawn for you. So if that's all you want, a linear model, then you're done, because now you already have the output, also, as we will see, the fit statistics and everything. Now, before we look at the output for the linear growth curve model, I want to show you too that there is an auto-completed version of this model that you can access here at the bottom. And so this auto-completed model drawing shows you which parameters the lavaangui adds by default that are not drawn, so to say, in the user model. So when we switch back and forth between the user model and the auto-completed model, then you can see that there are these dashed arrows here that indicate that variance parameters have been added for the growth factors. Also at the bottom here for the indicators, which you can see when you make this a little bit smaller, you can see there are also error variance parameters that have been included here in our model. And we have a covariance parameter as well between intercept and slope factor. On the right-hand side, you can see the syntax that has been generated. The lavaangui uses Lavan syntax. Lavan is a package in the R statistical software that is a general program for confirmatory factor analysis, structural equation modeling, and path analysis. And so if you want to learn Lavan syntax, then you can copy and paste the syntax from here, and then you could use this in the R environment to specify other models based on syntax, for example. Now, I told you that already the output has been generated for this linear growth curve model, and you can see that by clicking on estimates. So when you click on estimates, then you can see that there are values here that are now imported into this path diagram, specifically variances, the factor covariance, and the mean structure here at the top. That comes from the triangle. Let's see if we can see that again by applying a different layout. For example, tree. Now you can see this is a constant of 1 here that is representing the mean structure. So the means of the latent factors come from this triangle. Here the mean of the intercept factor is 32.54. The mean of the slope factor is negative 0.4. So there's a negative growth here, or we could say a decline on average in the IQ scores across time. You can also see that variances have been estimated for the intercept and slope factor, as well as for the error variances at the bottom. And then also there's a factor covariance here that is negative 37.36. You can also depict standardized parameter estimates in the diagram by clicking on View and then Standardized Estimates. This could be useful, for example, if you wanted to know what the factor correlation is. In a standardized solution, the factor variances are standardized to 1, and then this means now this gives you the correlation. So negative 0.39 is the correlation between the intercept and slope factor here. On the right-hand side, you can find fit statistics. You can see maximum likelihood estimation is used by default. When you have continuous variables, you can also run this model with ordinal variables. So when using ordinal variables, you would define them specifically by right-clicking on the variable and then saying change to ordered. Ordered means ordinal or ordered categorical. So in that situation, then automatically a different estimation method would be applied that is appropriate for ordinal data. Also, you can see there's a chi-square fit statistic that here is 6.869 with 5 degrees of freedom and a p-value of 0.231, indicating that the linear growth curve model is not rejected for these data, so it fits well. Also, you get other fit statistics, including CFI and TLI, RMSEA and SRMR. Here they all look good for this model, indicating a good fit of the linear growth curve model. If you prefer to see the results in table format, you can click on More Results, in which case this dialog window here opens, or output window, where you have all parameter estimates in table format along with their standard errors in the SE column. The EST column here indicates the estimate. SE is the standard error. Z is a test statistic for a test of significance of the null hypothesis that the parameter is 0 in the population. There's also a p-value provided as well as a confidence interval. You can choose the confidence level. The default is a 95% confidence interval. You can change that to, for example, 99% if you like. You can switch back and forth between unstandardized parameter estimates and standardized parameter estimates. You can also change the number of digits in the output. If you, for example, prefer to only have 2 digits, you can change that here. Furthermore, the output also includes modification indices. In case the model doesn't fit well, you can take a look at suggestions for how the model fit may be improved. There's also the residual covariance matrix provided for assessing model misfit in more detail. And under exact test, you can choose a robust chi-square test statistic. For example, in cases where you have non-normal data, you can click here on the left-hand side and select a different chi-square, such as, for example, the Satora-Bentler scaled chi-square test statistic, which takes into account non-normality of the data. So here the scaled chi-square is even a little bit better than the standard maximum likelihood chi-square. The p-value is somewhat larger, 0.36, but the conclusion would be the same. The model doesn't have to be rejected at the 0.05 level. Now, another thing that is interesting to know about is when you click on estimation, you can see that the default here is chosen, so that would be maximum likelihood. And then when you go to standard error, you can select a different form of standard error as well. So you could also pick robust standard errors instead of default maximum likelihood standard errors, or you could select bootstrap standard errors, which might also be useful in cases when you have non-normal data. Furthermore, when you click on missing data or look at missing value options here, you can see that the default is listwise deletion. And so this is something that we typically don't want when we have missing data. We want to use full information maximum likelihood instead of listwise deletion. And so then when we select full information maximum likelihood, you can see that the fit or the estimates change a little bit, because now we are taking into account all missing data, or all observations, including those with partially missing data. And so this is what we should typically do. Another issue could be that perhaps you don't want a linear growth curve model, right? So perhaps you are more interested in fitting a quadratic growth curve model, and then in that case you can add a factor to your linear growth curve model that represents quadratic growth. Now, how do we do that? We go back to user model, and then we can select another latent variable from the menu here. We drag that down, and then we give that a label. It's by default, it's labeled F1, which is maybe not what you want. And so we can rename it by right-clicking on it, and then we can, for example, call it quadratic. And then rename. And so then this becomes a quadratic factor. Now you can draw your paths from the quadratic factor to x2, x3, and x4. And when we click on auto-completed model, you can see that already the auto-completion function has added a variance parameter to this factor, as well as covariance parameters with the other two factors, and a mean structure, which is coming here from the bottom, which you can't see really well. Now you can see it. There's another constant of 1 here at the bottom that sends a mean also to the quadratic factor. So this is what we want in a growth curve model. And so this has already been added. Now what has not been added yet to our model are the relevant loadings. So the first loading is actually already fixed to 1, which is as it should be. However, the other two loadings are freely estimated, which is not correct for a quadratic growth curve model. So if you want a quadratic factor, you have to fix these loadings to relevant values. And so we can do that by right-clicking on the loading and then say fix parameter. And then we can enter the value to which this loading should be fixed. So the second loading, or the loading of the third time point on the quadratic factor, should be fixed to 2 squared, which is 4. So we enter the value of 4 and then OK. And then the loading of time point 4 should be fixed to 3 squared, which is 9. So we're going to right click on this loading again and then click on fix parameter, and then we enter the value of 9, so 3 squared, and then click OK. So then these loadings are fixed according to a quadratic growth. And now this quadratic model is done. So we can look at estimates again. You can see that then the output changed. We now get a different chi-square value that is 0.623, 1 degree of freedom, and a p-value of 0.43. So the quadratic model also fits the data well in this case. Thank you so much for following me through this video on how to specify latent growth curve models using the lavaangui graphical user interface, and I'll see you next time.